So we're going to go through the foldable. This is insane. Okay, here we go.
Foldable.
We made that. So if you don't have one, you can just write this in your notes.
I want to make a foldable. Please.
It's on video.
Oh, hi. Hi. Can I like put my face underneath there?
Go sit down.
No, but I need a foldable.
Okay, just write this in your notes. It'll be fun.
Do you have instructions?
Okay, the first property. A to the m times a to the n. You should see this on your first tab.
I just want to staple it.
Okay, you are going to be quiet.
Are we ever going to use those office files?
Maybe. Okay. A to the m times. Okay, listen. Yes, be quiet. It's over. We're learning. Do you understand? Do you understand?
Yes, ma'am.
All right. A to the m times a to the n is a to the m plus n. You add the exponents if you have the same base. So now we're going to do this with rational exponents. 5 to the 1/2 times 5 to the 3/2. When we're adding fractions, which is what we need to do, bless you, we need to have a common denominator. This one already has a common denominator, so I'm just going to add the numerators, which would be 4 halves. 5 to the 4 halves is the same thing as 5 squared, and 5 squared is 25. You can write this example in your foldable where we left a space. Yes. Okay, I want to do one more example. What if we had 5 to the 1/2 times 5 to the 1/3? Okay, we want to add this. We want to add the fractions together, but we need a common denominator. In this case, it would be 6. So if we have 1/2, this is like my scratch word. 1/2 times what to give you 6 on the bottom? 3. If we multiply by 3 on the bottom, we have to do 3 on the top. What is that? What is 3 over 3 equal to? 1. So if we multiply by something, if we multiply something by 1, does it change the value? No, it just changes the way it looks, right? Okay, so this would be 3 over 6. And then 1/3 times what? 2 over 2 is going to be 2/6. So this would give us 5 to the 3/6 times 5 to the 2/6, which is 5 to the 5/6. Right. Yes, it doesn't simplify. Yes, it is. Now we're number 2.
So 5 and 5, 6.
Yes. Yes. What? They have to have a common denominator. Right. So the common denominator would be 6. Okay. A to the m to the n. What happens when you have an exponent to an exponent? You would multiply a to the m times n. For example, if we had 8 to the 1/3 squared, this is like what we did yesterday. We have an exponent to an exponent, we would multiply. That would be 8 to the 2/3. Okay, our next property is a times b to the n, and we can move the m inside. A to the m times b to the n. Remember that you can only do this if the things in the parentheses are being multiplied, not added or subtracted. Okay, only multiply. Yes, ma'am. Okay.
On the first one, whenever we're doing like 5 fraction times 5 and fraction.
Yes.
I did the fraction stuff, but
Yep.
why don't we do 5 times 5?
If you look here, this just says that you add the exponents, not change the number.
If it was like 5 and 6
If it was 5 and 6, you wouldn't be able to do anything with it. Right. Okay, so a to the m times b to the m. So for example, if we had 16 times 9 16 times 9 to the 1/2, that would be 16 to the 1/2 times 9 to the 1/2. What is 16 to the 1/2? Square root of 16. 4, and the square root of 9 is 3, which becomes 12, right? So yesterday we learned that the half power is the same thing as the square root.
So why would we use that for number 2? Or is that just not?
Because it doesn't, well actually we could. I don't know why we didn't. Okay, what? If we go back to here, what's the cube root of 8? 2. So it's actually 2 squared, which is 4.
Wait. So is that how much to do it? Or can we do it
Probably the book is going to give you ones that you won't have to go back. But I was really just giving you an example to show you the property. Sabrina. Are you good? Okay. All right, number 4. A to the negative m is 1 over a to the m. For example, if we had 2 to the, no, let's do 16 to the negative 1/2. It's going to be 1 over 16 to the 1/2 to make it positive. And then what is 16 to the 1/2? 4, right? The square root of 16, remember? Equal.
Wait, why are we multiplying that?
What do you mean multiplying what?
Answer. Wait, is that an equal one?
Yes.
Oh.
Sorry. I bet it's been bigger. Okay. A to the m over a to the n, we would subtract. Again, the only way that this is going to be different is if we have, is that we're going to have fractions. So for instance, 3 to the 2/3 divided by 3 to the 1/6. What's the common denominator? 6. So I'm going to multiply this by 2 over 2. This stays the same. So this gives me 3 to the 4/6 over 3 to the 1/6. And when I subtract, that gives me 3 to the 3/6 or half. Yes. 1/6. 3 to the 1/6. It doesn't reduce to anything. Are you good? Shh. Are you good? Okay. A over b to the m, we can make that a to the m over b to the m. An example, if we had 2/3 to the 1/2, this would be 2 to the 1/2 over 3 to the 1/2. The major things to note when we're doing this with rational exponents are if we're going to add or subtract, we need a common denominator. Okay, so some examples. Yes. Yes. Okay, the first one. We need to do what to it? What are we going to do, like, in general? Add the exponents. Okay, in adding the exponents, I am going to need to kind of comment on there. What is it? 24. So 1/8 is going to be times 3 over 3, which gives us 3 over 24. 5/6 is going to be times 4 over 4, which is going to give us 20 over 24. So we'll get 12 to the what power? 23 over 24. Okay, for the next one. Are you sure? Remember when we have a to the m times a to the n? Okay. Are you good or no? Okay. Are we good? Can we move on? Okay. This example, we have 6 to the 1/3 times 7 to the 1/4, and all of that is cubed. What can we do with this? Right, we can cube each individual thing. So 6, okay, we have to the 1/3 and then cube. So what do we do there? What? Right, you would multiply, which will give you 3 over 3, which is just 1. Times 7 to the 3/4. Now, it's a common mistake students make. They want to multiply these together, but you can't. Unless they have the same exponent, you cannot multiply them together. So this is too bad. That's the answer. Oh, 6 to the 4 over 4? I mean, you could, but it's not. Then you just have a 4 over 4. It's not going to help you any. Okay. One fourth times 3.
So why would you do 3?
Are you good? Okay. 2 to the 6 times 4 to the 6 to the negative 1/6. What do you want to do first? Move the 1/6 inside. So we get 2 to the negative 1 times 4 to the negative 1. And then what do we want to do? Do you know? 1 over 2 times 4. We're going to move both of them to the other side of the fraction. It's going to make them positive. So it's 1/8. Okay, what about 10 over 10 to the 2/5? Okay, this would be 10 to the 5/5 if we're going to get a common denominator. And then we just subtract and get 3/5. Make sense? Awesome. Should have been here yesterday. I did just post the video for you though.
Yeah, I was like, gonna be a good girl, like do my homework and like, well, like watch videos so that I can do your homework. And I was like, well, we didn't put it on. Guess you have to make your homework.
I just want you to come to school.
I'm sorry, I overslept. I heard you for are you here? Yeah.
Okay. What is the cube root of 125?
Let me check it out.
5. What is the cube root of 8? 2. So this is 10. What if you didn't know that? Okay. The first thing, shh. None of you knew, so be quiet and I'll tell you. Okay, if we think about these as rational exponents, this would be 125 to the 1/3 times 8 to the 1/3. And since they both have 1/3, what can we do? You can take that out. So it's 125 times 8 to the 1/3. If they have the same base. Yeah, but they aren't really. So you could take out the 1/3 and multiply like this. But other than that, you can't do anything to it. So you could, that's what I'm saying. So you could multiply what's inside. Yeah. Yes.
Okay, so usually like the stuff is a little harder to do this in my cases. So would we ever get like we have 3 root 125? Would we ever have that times like 7 root 3? Like when the lower number is small down? Yeah, but it's not that big. Yes? If so, how
I don't.
it always tends to be like, okay, because you know, like they have the same exponents, so we put them together and then the cube root of 3, okay, whatever. But if they're not both 1/3, you can't do that, you know? What do we do?
I don't know that there's going to be one like you're talking about. Okay, while she's looking, I want to go over just a couple more problems and then we can stop and work on your homework for a little bit. Okay, remember when we did square roots and we simplified things that was just the square root of a number? And what we did was we did a factor tree and found all the pairs and took the pairs out and wrote them once. Do you remember this? It wasn't terrible. Alright, we're going to do the same thing with these, but you just need to know that they're whatever the index of the radical was, whatever root you're finding, you're looking for groups that are that big. So for a square root, we looked for pairs because the index was 2. For the cube root, we're going to look for 3. So we're going to draw a factor tree. What are factors of 104? 2 and 52. 2 and 26. And 2 and 13. Alright, so what happens 3 times? 2. So we're going to take that outside of the cubed root, and then we're going to leave 13 inside because it's by itself. It doesn't have Why what? 13 because okay, if you have, when you factor this out, you get 26 as one. So you have to do 2 times 13. The prime factorization of 104 is 2 times 2 times 2 times 13. Okay. All right, now, the reason you only have it out, or the reason you have a 2 out here and not a 2 inside is because we're looking for groups of 3, and when you find a group of 3, you're going to take it outside of the root sign and write it 1 time. which is what we did. We took the 3 2's out and wrote them one time. Yes. Yes, it does. Yes. Okay. 7 times the fifth root of 12 minus the fifth root of 12. What do you think it is? 2?
Is it 6 with the multiply root?
Okay, I heard 6 times the fifth root of 12 and 7. Which one is it?
Isn't it like an individual one? Never mind. Where is this?
Someone said 7.
I think it's 7.
Okay. Part of you. I mean, it can't be both of the answers. Okay, it's kind of like... It's kind of like 7x minus x. So if instead of the fifth root of 12 we had x, what would this be? 6x. And the answer is 6 times the fifth root of 12. Kind of like if you had 7 apples minus 1 apple, you would have 6 apples.
How about we just value?
Probably pretty high. The odds are pretty high. Okay, awesome. You can also do this if you have rational exponents. If we have 4 times 9 to the 2/3 plus 8 times 9 to the 2/3, this will be 12 times 9 to the 2/3. Yes. It doesn't, 9 doesn't have a cube root, so that's all.